Okay, so this is the second part of 3.3, the isosceles triangles. Okay, so we know what the area of a triangle is, right? We know that the formula for the area of a triangle is area equals 1/2 the base times the height. So in a triangle like this, we'll do it like this first. All right, this is your base, and your altitude is your height. If I have an obtuse triangle, again, this is your base. We might have to extend it for the altitude. That is your height. Last but not least, a right triangle. This is your base, and this is your height. So area equals 1/2 base times height, where the height is your altitude. Remember that word from the last video. All right. When we have a triangle, each triangle that we have has 3 altitudes, one from each vertex. So remember, the altitude is where we drop it straight down so it makes a right angle. All right, so you can see, let's try that again. Oops. So if I go in here and fix that. Okay, so it starts at C and goes all the way across and it forms a right angle. This spot right here, all right, where all 3 of the altitudes come together is called the orthocenter. Okay, it's called the orthocenter. So we're all 3, let's try that again. All 3 altitudes meet at the orthocenter. All right. Corresponding altitudes of congruent triangles are, just like you would think, are congruent, right? If we have 2 triangles that are congruent, then the altitudes are going to be congruent, okay? So one thing to keep in mind, the orthocenter can be outside of the triangle. Okay, so it is possible if we had all of this goes and all of them meet, it can be outside the triangle. So it can be outside. This orthocenter is actually pretty worthless in terms of geometry and what it's used for. This is only used for the 9-point circle. Alrighty, so you can look that up if you're really interested, but the orthocenter is only used for a 9-point, not center, it should be circle. It is the center of a 9-point circle. Okay, when we talk about medians, each triangle has 3 medians. So remember the median, we start at the vertex, we drop it down. Those are congruent. I drop it down. These are congruent. And then drop it over. These are congruent, and all of them meet. This pen is a little off today. At one spot, and where they all meet is called the centroid. Okay? So the centroid is always inside the triangle, every time. This is used when we talk about physics. So it's the center of gravity and the point of balance. So if I were to try to balance this triangle, This spot right here in the middle, right, where all three of the medians meet, is exactly where I would put my finger to balance it. All right, when we talk about angle bisectors, same thing, right? Each triangle has 3 angle bisectors. So if I draw them as best as I can, alrighty, the point where all of the angle bisectors meet is called the incenter. Okay, so the incenter, again, this one is always inside the triangle. Okay, this is, if you're interested, the center of an inscribed circle. Now, inscribed is just like what you would think. It means that I would draw a circle right inside, which just looks terrible, and the center would be the incenter, okay? So that is what I'm talking about when we talk about the incenter. Okay, just like before, each triangle has 3 perpendicular bisectors. Remember, a perpendicular bisector doesn't have to go through the vertex. It is a line that cuts, let's try that one again. Okay, so it is a line that cuts this in half and does that. This one would be very similar, like this. Again, and then if I do it for the third one, and it makes a right angle. The point where all 3 of the perpendicular bisectors meet is called the circumcenter. Let's write that again. So it's called the circumcenter. This can be outside the triangle, okay? So this is the center of the circumscribed circle. So that means I could draw a circle on the outside, and this guy would be the center of that circle, okay? Okay, so the bisector of the vertex angle of an isosceles triangle is going to separate the triangle into, it's going to separate it into 2 congruent triangles. All right, so let's see about that. So if I draw an isosceles triangle, okay, and I'm looking at the bisector of the vertex angle, so that means I'm going to be drawing a bisector right through here, meaning it's going to cut that angle, the vertex angle, into 2 congruent pieces. This guy is congruent to himself. Well, look at that. I have side, angle, side for that guy, side, angle, side for that guy. So I can say by side, angle, side, yes, this is true. If 2 sides of a triangle are congruent, then the angles opposite these sides are also congruent. So what that's saying is in my isosceles triangle, if those 2 sides are congruent, I go across, and that tells me that these base angles are going to be congruent. And this is the converse. If 2 angles of a triangle are congruent, then the sides opposite these angles are also congruent. So again, if I have my isosceles triangle and I tell you that these two angles are congruent, you can look and say opposite the angles that this guy has to be congruent to that guy. Last but not least, here's an important table I got out of your book that's selected properties of triangles. So if we're talking about a scalene triangle, no two sides are congruent, and all the angles add up to 180. No two angles are going to be congruent. Okay, so maybe that could be an important. Okay, so no two congruent angles. When we talk about an isosceles triangle, we have exactly two sides are congruent. All of these, right, we know that all of the degrees are 180. And we have two angles that are congruent, right, those base angles there. Equilateral, we also talked about the other day being equiangular. This tells me all three sides are congruent, which tells me that all of these angles are congruent, which means if we take 180 and divide it by 3, I get 60 degrees per angle. Okay, so that's important to remember when you talk about equilateral and equiangular triangles, that it's 60 degrees for each of those angles. All right, when we talk about an acute triangle, we could have 2 or 3 sides congruent, it just depends. All of the angles are acute, they all add up to 180, and we could have 2 or 3 that are congruent, it just depends. When we talk about a right triangle, we could have 2 congruent sides, and those would both be the legs. Okay, remember the legs can't be the same as the hypotenuse. Our handy Pythagorean theorem right there that we talked about. We're going to have 1 right angle and then 2 acute angles. Okay, they could both be congruent, it just depends. And if they are congruent, they're both going to be 45 degrees. Okay, and we also talked about this, came from your test, the relationship between this top one here and this right one here is that they both add up to 90 degrees, so they are complementary. Last but not least, we have our obtuse angle. The obtuse, we could have 2 congruent sides, right? These two could be congruent. We don't know. We're going to have 1 obtuse angle and 2 acute angles, and then they all add up to 180 degrees.